Hello. What we're learning today sounds kind of fancy, but it's really not. It's just putting together everything we've learned up until this point. And so our goal is to use inductive and deductive reasoning to prove triangle congruence. You all have been doing a fantastic job with mid-segments and also triangle congruence. I'm really excited. You've been working really hard, and I think we finally mastered triangle congruence. So there's 5 different ways that triangles are congruent, and you've done a great job with it. So today we're going to put it all together, and we're going to do one of my favorite things, which is proofs. And we're specifically just going to prove that 2 triangles are congruent. And so how do we do this? Well, to set up a proof, you always have your statements on the left and your reasons on the right. So let's always list your givens first. And so what do I mean by givens? What's a given? Well, it's marked, so it's when you have those tally marks in a picture, or it's told to you. Then you're going to have your body here, and that's going to be when you have to kind of take a closer look and see what you know to be congruent, but it just hasn't been labeled for you. And you know some theorems and some properties and some definitions that will be your reasons for those on the right. And then your last statement is always your conclusion statement. What is it that you're proving? So these are the most common properties and theorems that we will use in the reasons section on the body portion of our proof. So I will go over what the reflexive and the symmetric property mean with you in a minute. But we also have vertical angles. You all know that vertical angles are always congruent. It's when 2 lines cross at an X, the 2 angles across from each other are congruent. You know the definition of midpoint. Midpoint is a point that cuts a line segment in half. And then a definition of a bisector. Well, a bisector also results in 2 congruent segments. And sometimes they even make right angles. Not always, but sometimes. A bisector can also be an angle bisector, where it'll cut an angle exactly in half. All right, I promised that I would show you what the reflexive and the symmetric properties are. Basically, they say the same thing. It's whenever you have a triangle that has an angle or a side in common, that's when you can use the reflexive property or the symmetric property. And it doesn't matter which one you use, they both prove the same information. So it doesn't matter if I write A, B, A, B, that you can either call that reflexive or symmetric. Or if a triangle shares a common side of X, Y, you can change the order of the letters and you can still either choose reflexive or symmetric property. It's kind of like, they're like synonyms. They say the same thing. All right, so let's do a proof. Let's get down to it. So we got to prove that this triangle is congruent to this triangle. And we do that by first stating what's given. Well, I see that JL and LN are going to be congruent line segments from the way that the drawing is. And I'm just going to call that my given. So my statement is that they're congruent. My reason is that was given information. I also see that KL and ML are congruent. And I know this is given information. Now what I have to look in between and see is that this angle here is congruent to this angle here. And the reason I know that is because they are vertical angles. And a short way of saying that is just saying vertical angles are congruent, rather than writing the whole definition out. Slide that right there. And so then finally we can say for certain that our 2 triangles are going to be congruent as well. Put that in there. And we can say this because we've got a side followed by an angle followed by a side. So that is what we call side angle side theorem. And our proof is complete. We've got 4 statements to prove these 2 triangles are congruent. Let's do another one. All right, here we go. Let's start out. They're giving us information 2 ways. They're writing it and they're showing it in a picture. So the first thing I'm going to say is that PG is congruent to SG. And I can say this because it's given information. Cool. And then I can say that TP is congruent to TS. And again, that is our given information. All right. Now I got to start getting creative when I get into the body. Well, I see this side right here. This side is shared by both triangles, therefore I know that they're congruent. And this is where you have some choice. I can either prove that they're congruent because of the reflexive. Would you come with me, dude? Let's go. We're going in this little box over here. There we go. All right, and I know that you can choose either reflexive or symmetric property. It doesn't matter. It's up to you. I'm going to use a reflexive property in this one. And what I've noticed is that I have 3 congruent sides. This side is also congruent. So because I have 3 congruent sides, my proof is side, side, side. And my statement is, where is it? That the 2 triangles are in fact congruent. Yay. All right. It's much more fun when you have choices. Sometimes you have to come up with these all by yourself. So once again, we have to prove these triangles are congruent. If you want to pause the video at any point, try to fill the statements and the reasons in by yourself, and then come back to it, please do. Do that right now. All right, so I know my first 2 are going to be givens. What's given? AD is congruent to AB, and my other piece of given information is DC is congruent to BC. Now, you're not always going to have 2 congruent statements. You might have more or less, but for triangle proofs, you'll probably have 2. All right, next I see that they share this line right here. Because they share that line, I know that can either be the reflexive property or the symmetric property. In this case, I'm going to choose a reflexive property. And then finally, I can state that these 2 triangles are for certain. Come on, baby. There we go. They are congruent because they have 3 corresponding and congruent sides. All right, let's model another problem for you. All right, let's see. We've got AC is congruent to EC. Oops. That's given information. And what else do we have? We have BC is congruent to DC. Again, given information. Now, what do we got to figure out here? Well, I see these 2 lines crossing right here and making an X. So I can say for certain that these are vertical angles. All right, so where are they? There they are. Angle ACB is congruent to ECD because their vertical angles are congruent. And I can say these 2 triangles then are congruent because I have a side, then an angle, side, then an angle, and then a side. So it'd be side, angle, side. All right, again, proving 2 triangles are congruent. This one's a little bit different. We got to use a definition that we haven't used yet. So let's start with our givens, because that's where we should always start. We got JK is equal to NK, because that's given. And then I've got this weird, A is the midpoint of JN. That is also a given statement. Now, what does that mean is the question. Well, that means that I can say that this side here is congruent to this side here. I should use 2 tick marks because this is in the middle, so it's going to cut it in half. So where's my, here we go, what is that? That is JA is going to be congruent to AN. Now this is not the symmetric or reflexive property. This is saying that the definition of midpoint. These are not sides that the triangles have in common. They don't share the sides, but it's the midpoint that causes those 2 sides to be congruent. What I can say for certain is that this side is shared by both triangles. Come on. And so therefore I can say that this AK and KA, I can either say the symmetric or reflexive property on this one is causing those 2 to be congruent. And so finally, because I have 3 congruent sides, corresponding incongruent sides, I can say that these are congruent because of side, side, side. Yes, yes, yes. Okay. Where do I start? Again, like I said, pause the video. Try to do it on your own if you want to. Well, I start here with my givens, and this I know is given information. Well, let's see. I know the second piece of information is also going to be given. Let's see what it is. TRS is congruent to RTQ. All right, so I've got my two angles marked that are congruent. Where did that go? Just disappeared. There, it's back. All right. Now, what else can I also see that they share this side. And that side is what we call reflexive property or symmetric property. In this case, I'm going to use reflexive, and I'm going to call it TR and RT. There we go. And lastly, I can say that these two triangles are in fact congruent because we've got angle, angle, and a side. So that would be angle, angle, side right here. All right, let's do another one together, and then it'll be time. I think you'll be ready to practice. So once again, I'm going to start with my given statements. That one's given, and this one's given. All right, I'm going to say PQ is parallel to RS. Now there's a couple ways I can know that this is true. PQ is parallel to RS. One way is that these little arrows here indicate parallel lines. And I can also say that PRQ is congruent to SQR. And that's simply because of it's given. But we can also say that this is a transversal line across two parallel lines. So I can also say that these angles are congruent. And if you remember this from Module 1, those are called alternate interior. They're inside the parallel lines. So we call those alternate interior angles. So I can also say that these angles, these angles are congruent. And that is again because parallel lines cut by a transversal create alternate interior angles that are congruent. All right, so I'm almost done, but there's one more piece of information right here. The last statement here is that we can say that R and Q, this side is shared among both triangles. So I can say that these two are in common. I could say reflexive or symmetric property. And then finally, I can conclude that these two triangles are in fact congruent. And the reason I can say that is because I have an angle, a side, and an angle. So that would be angle, side, angle. All right, y'all, if you have any questions on how any of these statements or reasons were given for each of these triangles, raise your hand. I'll come around and help you. And it's time now. I think you're ready for some practice. So good luck. Remember, the test on all this stuff, Module 2 test, is next week, Tuesday. Peace out.